Hi everyone. So in this session, we are going to talk about API specification and microservices communication patterns with GRPC. So I'm Kasun Indrasiri and my colleague Danesh will join in the middle of the session. So in this talk, we are going to primarily focus on some of the key communication patterns that you can build with microservices and GRPC and how you can extend API specification to API specification when building those patterns. So let me get started with a brief introduction to gRPC. So I'm sure most of you are familiar with gRPC or have at least have heard of gRPC. So it's a modern inter-process communication technology that allows distributed applications to communicate with each other over the network. So the primary focus of gRPC is to allow a remote application to invoke a another remote application over the network as easy as making a local function call. And this protocol is built on top of HTTP2 using protocol buffers as the message serialization format, which using the wire. And this is inherently a contract-first protocol, which means you define the service interface using the service definition language, and then you generate service side and the client side stuff so that you can build, produce, and consume them both sides. And this protocol by default supports the polyglot application development, which means you can build your service side using one programming language, whereas your client can be developed using a completely different programming language. Now, so service definition is the most important aspect that we will look into in today's session. So let's go through a quick overview of the service definition. So this is a simple service definition of a gRPC service. The main items of the service definitions are the service specification itself with the service name and set of the whatever the remote methods that you want to expose. And all the types, all the messages that you would use in those remote functions can also be specified using this protocol buffer service definition. So, so once you have the service definition in place, then you can generate your client or server-side stubs. So as part of the server-side, what it provides you is there are multiple language plugins so that you can generate code for the language, programming language of your choice. So you basically use the same service definition and generate the server-side code. So in this case, what is generated as the stub is the all the boilerplate code required for internal wire-level communication so that you can only focus on the business logic of your gRPC service. So once you have the gRPC service, then you can start a gRPC server runtime, basically registering whatever the service that you have with the server runtime. So it runs on a specific host and a port address. So this sample code is given for Go, and you can find any other samples related to the programming language of your choice. And client side is pretty similar. You use the same service definition and generate the client stuff. And so you basically invoke the remote method as easy as making a local function call here. And if we look at some of the advantages that gRPC brings into the picture, so it's an efficient protocol. So unlike most of the other protocol, this is using binary protocol buffer-based binary messaging as the wire-level protocol. And owing to its performance, it's a very efficient protocol, especially very suitable for the internal microservices communications. And also, since this is based on the contract, so we define service contract upfront, and all the required message types are defined as part of the service definition. So by default, this is strongly typed way of developing distributed applications, and type safety is already built into your applications inherently. And as I said earlier, this is polyglot. You can use any programming language of your choice. And And unlike most of the other request response style communication protocols, this is also supporting duplex streaming, which means you can send messages in both directions at different sequences. So we'll go into some of the details later. And also this is part of a broader ecosystem, which is this project itself is part of the cloud native ecosystem. And there are multiple other projects adopting GRPC as a technology. So there's an increasing growth of the popularity and adoption of GRPC. Now, if we compare gRPC with other protocols such as REST with OpenAPI or GraphQL, there are some major differences. So using binary as the wire level binary protocol, buffer-based binary protocol as the wire format is the main difference. And also we follow strict contract here in gRPC. So you always have to define the service definition. And with compared to other protocols such as GraphQL, so this is based on the concept of a remote method, whereas GraphQL is pretty much about sending queries to your service, and service behaves based on the queries. And if you look at the application of gRPC in the context of microservices landscape, so we often see this as a great candidate for use inside your microservices implementation, which means your internal microservices communication. Whereas when you have to expose some capability, of course, you can expose it as a gRPC service, but owing to lack of support in certain web clients and browsers, we usually expose most of these services as a RESTful or a GraphQL interface, again, through an API gateway layer. So again, what we want to envision here is this is gRPC is so not a silver bullet technology, but it should be you can use it alongside other popular technology. So based on the use case, you can select different protocols and you can let them work together to build a particular use case. So let's look at some of the common message patterns that you can build with gRPC. So obviously the first one is simple RPC or Unary. So where you invoke a remote method from the client side. In that case, you are sending a single message and you are getting a single response. So it's very straightforward use case. So the second message pattern is you invoke a particular remote method, but you can expect more than one response. So this is, here we call this is a stream. So, so this is server-side streaming. So from the server side, you can send multiple messages in a given stream. So once server starts sending a stream of messages, then it can decide when to mark the end of the stream, and then the consumer can read all the messages that are coming in the stream. So the stream definition goes as part of the service definition itself. And if you look at this protocol buffer definition, where you can find search order method with return type as a stream. So in the previous case, we only had an order, and in this case, we have a stream of orders. So the same concept can be applied for client side. So in this case, we are sending a stream of requests, and server can either wait till it receives all the requests from the client side, or it can send the response when a particular condition is satisfied. So as you can see, the request parameters are now becoming a stream, and return parameter is just a single value, just a single request. So all those things are specified in this service definition. So the combination of the two is bi-directional streaming. So from both sides, you can send a stream of messages. So for example, in this particular use case, we are sending a set of order requests, and then order management service create process orders and create different shipments. So shipments are again a set of messages that are coming in the server-side stream. So in this case, service definition is given as stream in both cases for both request parameter and the return type. So another very useful concept in GRPC communication patterns is GRPC interceptors. So this is a mechanism to execute a common business logic. So it doesn't need to be a business logic. It can be a common or like a commodity logic that prior to the execution of the remote function. So this is very useful when it comes to the implementation of things such as login, authentication, policy enforcement. And so there are multiple types of interceptors. So you have Unary interceptors, streaming interceptors. Unary allows you to intercept a single request, whereas streaming interceptors can be used to intercept a stream of messages that are coming in or going out of your gRPC service or client. Now, we talk a lot about various communication patterns and how those patterns are specified in the gRPC service specification. And API definition or the service interface definition is a key aspect of gRPC. So by default, what it supports is the service definition, remote methods, and whatever the types that you would use inside your service. So those are the things that you can support out of the box from gRPC protocol. But when you have to implement certain features such as authentication, authorization, or policy enforcement, and even versioning, so you can extend the existing service API definition of gRPC and bring in whatever the features that you need to have to the service definition itself. So that now when you have those things specified in this in the service definition as extensions, the server side or the client side can process them and incorporate them in the runtime. For example, you can specify a particular service policy, authentication policy as part of the service definition, and the service implementer or the consumer can consume it and leverage it inside the implementation. So in the rest of the talk, what we are going to focus is on those aspects. So we'll look at how we can implement versioning, how we can implement authorization, authentication using service definitions of gRPC. So Danesh will take you through those use cases, and we'll go through some of the demo as well. Over to you, Danesh.
Thank you, Kasun. So I will go to some of the key aspects of API specification. So one of the key objectives of API specification is API versioning. So the reason behind API versioning is the services should strive to remain backward compatibility with the all clients. And also, if you have a better versioning strategy, it will allow us to introduce breaking changes to our services and etc. And in gRPC perspective, we are specifying the version number in the service package itself. So if you look at our proto definition sample mentioned in the slide, there's a service called order management, and in package, we are append the version number to that package. So let's see how it's work. So in gRPC, as you know, it's on top of HTTP2 transport. So whenever the client called a remote function, underneath it generates a post request. That post request, the endpoint part will be generated using package name and the service name and the method name. So if you are changing the version number in the package, appending the version number in the package itself. So whenever the version number change, the endpoint path will be changed. That will not affect the old clients which are using old version of the same resource. So these logics, the client application developer, as a client application developer, we don't want to worry about these underneath logic, because all these stuffs are handled by this generated stub itself. So let's say you are currently using the old version of the service and you need to migrate it to the latest version. What you need to do is we need to regenerate the stubs using the correct protobuf definition. Then you are redirect to the correct version of this latest service. Okay. Next thing is extending service definition. So when we are building a service definition, you may need to extend the service definition and add more options related to authentication, authorization, policy enforcement, etc. So those are supported by protocol buffer definition language. So they are supporting in different levels. So we can specify it at file level or at service level as a service option, or method level, or and the field level. So in my slide, I captured 3 examples where we using service options, the method options, and the field options. In the service options, so let's say we have a service called order management, and that service is secured through auth2. And whenever the tokens come from the client, we have an external auth server to validate the token. So that external auth server endpoint URL can be configured inside this definition itself. So what we need to do is we need to specify the option, define that service option, and then use it inside the service. The next use case will be like, let's say in your remote function, you need to control the traffic comes into the function. In that case, you can specify throttling tiers as a method option, and we can use inside your particular function and define throttling tier numbers. The other use case will be, let's say you have a function that the incoming message have some sensitive data in some of the fields. So those fields can be marked as sensitive by defining a field option called sensitive and use it inside the message itself. The next, let's look at a simple example how we use service options to our service definition. In our use case, I am secure. I have a GRPC service which is secured using auth2, and in this example, the service name is auth management, and the auth provider URL is defined inside the protobuf definition, and inside the interceptor we are accessing that metadata to validate the token. If you go through the diagram shown in the right hand side, we have the GRPC service and we have the interceptor, and whenever the client request come into the service, the interceptor will validate the token from the with the auth server register external auth server. So let's go and see the code. So this is the code which have the same use case. So this is the protobuf definition I have. We have order management service, and we have 2 remote functions, add order and get order. So here we are defining a custom service option to pass auth2 provider URL, and that option is used inside the service definition to and pass our URL. For us to define these options, we need to import descriptor.proto file. So that's it from the service definition side. Once you define the service, you need to generate the code. I already generate the code to save the time. So let's go to the service implementation. So if you are familiar with Golang, and if you are already create GRPC application using Golang, you will be familiar with these codes. So I will quickly go through what's need to be done. So first, we need to initiate a listener with a port, and then you need to load via loading certificates for enable TLS within client and server. And then we are registering Unary interceptor. This validate token I will talk in a minute. And then we are initializing gRPC server and registering our service to that server. So this is the part I need to highlight in this demo. So once you register the service to the server, you can load the service descriptors from gRPC reflect package. So this service descriptor contains all the data we configured in the protobuf definition. So from the service descriptor, we can get service options. From that service options, we can get the value we defined in the for against or to provide the option. So that value here we are saving in memory in memory map against the service name, so that we can use it later in our interceptor code. So and also I print the service name and the or to provide the URL which is get from the protobuf definition. Let's go to the interceptor function. So in the interceptor function, what we first do is we retrieve the metadata from the client request call. From the metadata, we are getting the auth token from the authorization header. We are passing it to a local function called introspect token. In that introspect token token function, we get the token which is coming from the client, and we get the auth to provide the URL which from the in-memory map which is saved earlier. From that, we are do a HTTP request for our external auth server to validate our token. Once the response contains whether the token is valid or not. Okay, that's it from the server side code. We will quickly go to the client side as well. In the client side, first we fetch the token to call the RPC. And then we also load the certificate for TLS connection. So all these credentials, the channel credentials and the call credentials are added to the dial option so that we can set up a connection between client and server. Once the connection is set up, we create a stub object. From the stub, we are invoking add order method and the get order method. That's it from the client code. Let's run the code and see what's. So I already built the code. So I just running the server now. So first we will run the server. So you can see we are starting order management service, and this is the order provider URL which is specified in our protobuf definition. Let's go to the client code and run the client. So you can see order management get add order and get order functions are invoked successfully. If you go to the service, you can see the first we get a add order request, and we fetch order provider URL from the in-memory map we stored. And this is the result we get it from the external auth provider. And the active equals true means the token we validated is correct and active, so that we are proceed with the resource processing. The same flow applied to the get order function as well. So the main, in summary, what I need to mention is how we define service options in the protobuf definition and how we use inside our service application. Okay, then let's go back to our slides. The next slide will be Another common application of using these option params in our protobuf definition is GRPC Gateway, which is also known as HTTP JSON transencoding for GRPC. So GRPC Gateway is a way of exposing our GRPC service as a RESTful service, so that REST client can invoke our gRPC service directly. So in order to do that, we need to add method options to map our remote functions to our RESTful resource. So these method options are already defined in the annotation, the proto file. So we just need to import that in our our service definition and use it to map those remote functions. So once you map all the functions correctly, in Golang, there's a client tool to generate the reverse proxy service, and also there's a tool to generate open API definitions. Okay, that's it from our presentation. So in our presentation, all the source codes and all the samples are taken from our book, gRPC Up and Running, and all the samples are there in the GitHub repo. You can access those things using gRPC Up and Running.github.io link. Okay, thank you for listening. Thank you for joining. So over to you.